Let's go ahead and work out this limit problem. So here we're taking the limit as x approaches positive infinity. So when you have limits involving infinity, the idea here is to pretty much simplify the function as much as we can by the following way. So you look at the highest power of x in the denominator. So this is the denominator, and the highest power here, so the highest power of x in the denominator is x to the 1 power. So we take that and divide every single term of this function by that power or the term we just selected. So I do the following. I have the limit as x approaches infinity of 2x over x plus 5 over x divided by x over x minus 9 over x. Once I do that, I simplify this as much as I can. So this is equal to the limit as x approaches infinity. So here, 2x over x, well, that's simply 2. And then 5 over x, that's just 5 over x, doesn't simplify. Here, x over x, that comes down to just 1. And then 9 over x doesn't simplify. Once you simplify, then using the limit laws, you can break this into different pieces of limits. So first we take the limit as x approaches infinity of 2 plus the limit as x approaches infinity of 5 over x all over. You take the limit as x approaches infinity of 1 minus the limit as x approaches infinity of 9 over x. So now you take these individual limits. Now the limit of a constant, of course, we know that's going to be the constant itself. So that's 2 plus, now what about this one? So as x goes to infinity, 5 over x becomes very small because you're thinking of plugging in large number for x. So 5 over 100, 5 over 1,000, overall it's going to go to 0. So we'll say that limit is 0. And this limit right here, limit of a constant, again, it's that constant, it's 1. And then, of course, this limit right here, 9 over x, same argument as the previous one, 5 over x, that limit is also 0. Therefore, this limit is 2 over 1 or simply 2. So the limit of this function is simply 2. Let's go ahead and try this limit problem. So we'll do the same thing as we did previously. We're going to take the highest power of x from the denominator, that happens to be x to the 4th. And now we grab that and divide every single term by that term. So you have, so this is going to be a lot of writing, but be patient with yourself. So I have 5 over x to the 4th plus x cubed over x to the 4th plus x to the 5th over x to the 4th all over 1 over x to the 4th minus x squared over x to the 4th plus x to the 4th over x to the 4th. And now we simplify this. So this is the limit as x approaches infinity. So this one right here, 5x over x to the 4th, well, that's going to give me 5 over x cubed plus, now this one gives me 1x on the bottom. So I have 1 over x. And the last one gives me just x because I have x to the 5th over x to the 4th. And on the denominator, 1 over x to the 4th stays as it is, minus x squared over x to the 4th, that's 1 over x squared, plus x to the 4th over x to the 4th, that's 1. Now you can do the same thing we did before, push the limit inside and take the limit of each individual term. But I think we can analyze that without writing it down. So if you take the limit as x goes to infinity for this one, well, that's going to go to 0 because you have 5 over a very large number. Now this limit will also be 0 as x goes to infinity. So then this limit, well, that we need to work on. So I have 0 plus the limit as x approaches infinity of x. So the reason I'm not writing the previous one because there's 0. Now on the bottom, this one will go to 0 because as x goes to infinity, 1 over x to the 4th goes to 0. Now this one, as x goes to infinity, that will also go to 0. And then we only left with limit as x goes to infinity of the constant term. And this is simply, now what is this limit? Well, as x grows, well, you're just getting large and large numbers. So we can say that that's infinity over 1 because limit of a constant is 1. So that's infinity. So this limit is infinity. All right, so here's the last example we're going to work out. Now, for this problem, well, there is no fraction, right? So we cannot use the previous idea we talked about. So we kind of want to estimate and come up with a value or an answer for this. So I'm going to try to show you this way. So if I try to factor the common term, so I have the limit as x approaches negative infinity, I can pull out an x to the fourth, and then I have 1. So this is a 1 plus x. And now let's try to sub in infinity, or think about subbing in infinity. So as x goes to negative infinity, well, what happens to this one? So you're plugging in lots of negative numbers, and that looks like that's going to go to infinity. And then here you have 1 plus, and then you're plugging in, kind of plugging in negative infinity for x. So that's a negative number, so large negative number. So overall, everything is going to go to negative infinity. So you can think about it, because the degree of this one is greater, the higher power is, eventually that's going to take over the smaller power. So because you're approaching negative infinity, when you take fifth power of a negative number, it's going to be negative. And this is one way to justify that. So the limit of this function will simply be negative infinity. I hope this makes sense. Take care.